So what we'll do is a past paper. We'll do the latest past paper. This is SACAI's 2015 paper 1. It's just written like 2 months ago. And we're just going to work through and kind of do a memorandum, I suppose, for this paper. So question 1.1.1 was the question. The question asked to solve for x. So we had x minus 4 is equal to 12 over x. Okay, so Tukuta, what would you do in a question like this? How would you know to solve this? Excellent, so everything gets multiplied with x. So x squared minus 4x is equal to 12 on this side, because if I multiply this with an x, I have a square, 4 times x, and on the other side, if I multiply with an x, the x's cancel. And that was the whole idea. And in the end, this is a normal, very simple quadratic equation. So we make everything equal to 0, factorize into 2 brackets. This is things you should do without having to think. Okay, yeah, it's things that should be so practiced in, we can't be explaining it. Okay, so 12, what gives me 12? And when I subtract, I get 4. 6 and 2, and we must get negative 4, so it must be negative 6 and positive 2, and that gives me x. So for this bracket to be 0, x must equal 6, and for that bracket to be 0, x should equal negative 2. So there's our first question. The next one, number 1.1.2, we have the square root of 3x plus 10, and then outside of the square root, a negative x is equal to 2. Okay, how about now? What do we do this time?
We multiply all the values with square root to cancel.
Okay, so you want to multiply everything with the square root. Okay, so actually when you see a square root in an equation, the first thing you need to do is solve the root. In other words, get the root by itself. So in other words, we don't want something else to be on this side. So I can't square, because I'm not multiplying with a square. I'm going to square both sides to get rid of the square root. But if I square both sides now, I won't be getting this. There's 2 terms, so I have to put 2 brackets and multiply it out. So rather, what I'm just going to do is I'm first going to solve the square root. In other words, I'm just going to get the square root by itself, and then on the other side I get x plus 2. Now I take the square on both sides.
So it's not possible to square root 3x plus 10 on its own, and then x on its own bracket.
No, because remember, what I do on the one side, I must do on the other side. So it's not what so for example, I can't do things to terms separately. I do them to both sides at the same time. So I can square this side and I can square that side. I can't just square this and square that and square that. Let me give you an example, okay? 3 plus 4 is equal to 7. Now let's see if 3 squared plus 4 squared is equal to 7 squared. Okay, let's see if that's true. 3 squared is 9 plus 4 squared is 16. 7 squared is 49. Is 9 plus 16 49? No, so I can't square terms. I can square the whole expression. So I could have said, well, 3 plus 4 is equal to 7. I could have said, well, if I take everything this side and I square it, it will be equal to everything on that side squared. And that's true. I mean, you can see that. So in this case, even let's say if we didn't multiply, we could have multiplied it 2 brackets. We could have had 3 times 3 is 9 plus, and then in the middle term we would have had 3 times 4 times 2, which is 24, and the last term would have been 4 squared, which is 16, is equal to 49. Let's see, 16 and 24 is 40, plus 9 is 49. Okay, so yes, we'll first have to solve the square root, get it on its own. Then we square both sides, that gets rid of the, so we'll do that. But you must remember, the moment you square both sides, you are giving a question 2 answers. Okay? One of the answers might not be applicable. So the moment I square, I'm saying, initially it maybe didn't have 2 answers, but the moment I make x squared, now it will have 2 answers because it becomes quadratic, isn't it? And now one of the answers might not be applicable. So keep that in mind, because the moment I square, I'm going to have to test my answers in the end with my original. Okay, so here I get 3x plus 10. And this one, if I multiply it out, I get x squared plus 4x plus 4. It's a quadratic equation now, so we just get everything by itself. So it's x squared plus x. And then the 4 and the 10 goes that side, that's negative 6 is equal to 0. Okay, you know what I'm doing, huh? Even if you can't calculate it as quick as me, you know how I'm getting there, isn't it? Okay, 2 brackets, I think this goes to 2 brackets. We must have 6, and when we subtract, we should get positive 1. So what must that be? Okay, you must practice this, you must be able to do it quicker, okay? 6 and the difference is 1. What times what gives me 6? 2 and 3 gives me 6, and they have a difference of 1. Do you see? That's what we have, the difference of 1. It's a positive 1, so we'll have positive 3, negative 2. Okay, so x is either equal to 2 or x is equal to negative 3. But one of these values might not be applicable. Okay, we'll have to first check. We'll have to put both in there and see if we get an answer of 2. We have to test it. Okay, so if we put in 2, then 3 times 2 is 6, plus 10 is 16. The square root of 16 is 4. 4 minus 2, because x is 2, gives me 2. This one, a-okay, you can go. Negative 3. Negative 3 times 3 is negative 9. Negative 9 plus 10 gives me 1. The square root of 1 is 1. 1 minus 3 equals negative 2. Can you see how if we had the answer in here, so for example in this case, if I substituted in here, I would have gotten an answer of 1, and on this side x is now negative 3 plus 2, which gives me negative 1. But because I square it, both gets the same answer, and that's what happened. The moment I squared both sides, I made a 1 equal to a negative 1. Okay, and that's why this one is not applicable. Make sense? Okay, let's do question 1.1.3. Okay, so 1.1.3. Any questions about the previous one? Okay. In question 1.1.3, they give us 3x squared plus 2x is equal to 1. Any ideas? Yeah? You'll make it 3 to the power of? But 3 to the power of 1 is not equal to 1. So you've got the right idea but the wrong values there. What should it be? 3 to the power of?
What about the left hand?
No, you're right, your idea is correct, because if I can get both sides the base the same, It must mean that the exponents are the same. But when will this expression be equal to 1? 3 to the power of what is equal to 1? No, let go of that calculator. 3 to the power of what? Exactly, so it's not 3 to the power of 1, 3 to the power of 0 is equal. That means that exponent, if 3 to the power of whatever is equal to 3 to the power of 0, it must mean that whatever is up there is equal to 0. Does that make sense? Now we factorize this. Just remember, just because there's an x squared doesn't mean it's always 2 brackets. The first we always do is take out a common factor. There's a common factor, x and an x in both of them. While we couldn't do it here because there's not a common factor in the 6. That's why this is a trinomial 2 brackets. This is 2 terms, both have an x in, and that's what I'll first look for. So I take out an x as a common factor, and I'm left with x plus 2. That means either this bracket, it's actually a bracket, is 0, or that bracket is 0. This bracket is 0 if x is equal to 0, and the other bracket is 0 if x is equal to negative 2. Questions? Okay, then question 1.1.4 gives us 5 in front of a cube root of x minus 40 is equal to 0. What do you think we're going to do first? Similar to what we did before.
Is it possible to multiply or move what to the other side and multiply this side and the square root of 3?
Okay, so again, we're not multiplying both sides with the square root of 3. We are cubing both sides. And you can do that, yeah, that's fine. Okay, so 5, so now we have 5. The cube root of x is equal to 40. I would suggest, before you cube both sides, that you just divide both sides with a 5. Just get the cube root, but this time it wouldn't make a difference. It will still work out, because I have a single term on this side, and or whatever, I'm cubing the whole side if I were to do it now. But just make it simpler. Look how it simplifies. The cube root of x is equal to 8. So if we cube both sides, x is equal to, and it's so sad, but I'm sure you're going to use your calculator. Put that thing away. There's only 2 parts in the test you should use your calculator. That's financial maths and the last question, probability. Okay? Don't use your calculator. Questions? Okay, so let's go to question 1.2. It's a fairly complex question. So 1.2 asks, let's get to the Afrikaans side of this question paper. Oh, sorry, the English side. For which values of m? For which values of m will the roots of the equation x is equal to negative m minus 3 plus minus the square root of this ridiculous expression m minus 3 minus 4 to 8. Everything, oh, that's squared. Everything over 2 times 2. Be non-real. This is totally, utterly just to intimidate you. It's a very simple question. When do we have non-real roots? Yeah? Excellent. So when m minus 3 squared minus 4 times 2 times 8, when this is negative. And this very complex question immediately, this is at least a level 3 type question, immediately simplifies to a quadratic inequality. Okay, so we've got m squared. I think there might be an easier way to do this. What is 4 times 2? That's 8. Yeah, okay, so let me show you a quick way to do this. Okay, so m minus 3 squared minus 64 is smaller than 0. Now notice this is the difference of 2 squares. You see, there's a square. So difference of 2 squares goes into 2 brackets. One has a plus, the other one has a negative. What gives me 64? 8 times 8. And then just whatever is under the square root comes in here. So m minus 3. And this is not m plus 3. Still m minus 3. It's just this one that gets a plus minus. So that must be smaller than 0. So I get that m minus 11 and m plus 5 is smaller than 0. Now how do we go on from here? Do we just say now m is smaller than positive 11 or m is smaller than negative 5? Is that how we do it?
Yes.
No. This is not an equation. It's an inequality. The moment I get to this step, I draw a rough parabola. Number line with a rough parabola. I put these two values on there. We have 11 and we have negative 5. According to our inequality, we use the negative. I just want to show you here, if you didn't see the difference of 2 squares, you could have just multiplied it out. Okay, you could have just said, well, that's m squared minus 6m plus 9 minus 64, and you would have gotten 6m, negative 64 plus 9 is plus 55. How do we get 55? Okay, 11 times 5, and then we have the 11 and the 5. Okay, see, it would have worked the same if you just multiplied it out. So if you don't know what to do, just go back to the basics. Okay, now next what you do is everything smaller means we're using this part of the graph. Okay, that means we're going between negative 5 and 11, but they're not included. Sorry, I shouldn't have drawn that one like that. They're not included because this one is not included. So in other words, m is smaller than 11, yes, but m is not smaller than negative 5, it's bigger than negative 5. You see why just doing this won't work. We have to draw the sketch. There will be an inequality. Okay, so let's do question 1.3. Question 1.3 gives us, they say, if 5 to the power of negative x is equal to 10m, express 2x minus 1 plus 2x plus 1 over 5 times 10x in terms of m. Okay, so we must try, since we can replace everywhere where there's a 5 to the power of negative x, we can replace it with 10m. We are going to have to find a way of writing everything here as 5 to the power of negative x. Now, it's impossible to write something that has a base 2 as a base 5. Well, it's not impossible, but it's definitely not high school maths. So we must know that somehow 2 to the power of x is going to cancel away. Okay, So 2 to the power, so that's the first. So again, if you don't know what to do, go back to basics. You just know, well, simplify this expression. If you don't know what to do, just go back to basics. So 2 to the power of x times 2 to the power of negative 1 plus 2 to the power of x times 2 to the power of 1 over, so you can see I'm prime factorizing. I'm just writing it as factors. 5 can't prime any further, times, and this 10 to the power of x can be 2 times 5 to the power of x, but be very careful. It's not 2 times 5 to the power of x. This is in brackets. 10 has an exponent of x. So it means 2 has an exponent and 5 has an exponent. So 2 has an exponent and 5 has an exponent. So let's say up to this point you still didn't know what to do. How about now? Do you have an idea now?
Can I separate 2 to x and 5? 2 to both x and 5 to both x. Can I separate it?
No, we can. They're factors now. They're separate.
So we remove 5 to the and it becomes 5 to the 12 x.
Good. So this one can go to the numerator and become 5 to the power negative x. That's exactly what I want. Okay, but what am I going to do with the rest?
It's 2x.
2
to the power x. And cancel the 2 to the power of x on top.
Okay, just one of them.
No, both.
Both. We have to take it out as a common factor. Okay, so 2 to the power of x is taken out as a common factor. So I get 2 to the power of negative 1 plus 2 to the power of positive 1 is what remains. Very clever idea, that one of yours, to put 5 to the power of negative x at the top, because then we have that 10m that I'm trying to replace. Okay, at the bottom I'm just left with 5 times 2 to the power of x, but this one and that one is going to cancel, and now I can simply do exactly what you suggested. Okay, here this 2 to the power of negative 1 is a half, plus 2, that's 2.5. Okay, so 2 comma 5 divided by 5, and then in the top I also have a 10 times 10m. And now I can see, well, this 5 goes into itself once and into 10 2 times. Different ways you could have simplified this. 2.5 times 2 is 5m. Okay. If you don't know what to do, go back to basics.